Hey everyone, welcome back to Pawpaw's Workshop. In today's video, I'm going to be taking the XCarve and I'm going to put a new wasteboard on it. Now, a couple of years ago, I upgraded the XCarve, and one of the things that I wanted to do at that time was put the new wasteboard on. Well, things didn't work out and I left the old wasteboard. Well, today we're going to replace this wasteboard with a similar one. The plan is to use the same design that I used on the CNC for Newbie new carve machine. This has worked absolutely fantastic, and I love this new wasteboard and the clamping system that I have. So I'm going to do the exact same thing. When I designed the grid work that I carved into the wasteboard, I used the XCarve Pro. And today I want to be using the Easel software to set up the same program. Now this is the original wasteboard that I put on this machine when I bought it. Now this is actual particle board. This is not medium density fiberboard. And if I had to do it over again, I would use the MDF or the medium density fiberboard. The particle board has served its purpose and has done well. And if I remember correctly, I bought this machine back in November of 2016 or thereabouts. Don't quote me on that. And this is the original wasteboard that I had put on. And this actually is the high spot. This board has been chewed away in this area, and this is a little bit lower over in this area. And it's about a 1 millimeter difference from the high point to the low point. So the first thing we're going to do is surface this entire wasteboard, and then I'm going to add the new wasteboard on top, just as I did with the CNC for Newbie. Now the first step is to find out exactly the space that I need to be able to surface. And I have right here the old grid work that I hand drawn, and I don't recommend that. And that's something that I no longer do. But I have the XY0 home position right there, and this red line actually was my do not exceed line. I did not ever want to go beyond that point. So that was a good reference for me, and yeah, that was just drawn in. This is my other reference point right here. I really don't want to go beyond that point. First thing I want to do is show you how I set up the bit. Now this is 1 1/8 inch bit. And when you click on the bits, you have this section right here where you can just click add a bit. And when you do that, you get to see your whole entire library of the different bits that you have. Now this is the surfacing bit that I have, and I've already entered it, but I still want to show you exactly how I did that. And you're right, no, the picture does not show an 1 1/8 inch diameter, but it's actually there. So let's click on add a bit, and you get a drop-down menu where it's custom or the inventables. Well, I'm using the custom. So you type in the name, and I put in the surfacing bit, and then you get to put the type. Well, it's basically an end mill, but you can see a wide variety of different choices. So I'm going to select the straight bit because that's the best option that I have, and then it brings you up to the size. And this is where you put in the 1.125, and then you can hit save. Now I'm not going to hit save right now because I already have it in my library, but that's the process that you go through to set up a new bit. And oh, by the way, if you click on add bits and select on the inventables tab, then you get to see the entire library that's available to you from inventables. And yeah, they do have the pictures of these. So you can find the bit that you've purchased from the inventables, you can select it, you can save it, and it will add it to your library. Okay, let's get back to surfacing the board. Now based on those measurements, I need to be able to have an area that's going to be surfaced as 28 by 28. The thickness doesn't really matter. So at the drop-down menu, I'll pull out a square, and I'll change the size of this to the 28 inches by 28 inches. And I can do that right up here on this little drop-down menu. Now the easiest way is just to lock that little tab right there, and then I can just type in the 28 inches, and that will take care of it. So you see where I locked it, then I'll just type in 28 inches, and that gives me a 28 by 28 inch square. From there, I can come up to the edit menu and select center to the material, and that brings it down and puts it directly on top of the work area that I have established, which also is the 28 inches by the 28 inches. Now as far as the cut depth, I don't want to cut it down very much. I'm going to cut down 0.06 of an inch, which is about 1.5 millimeter. and that's going to be my start point to surface the wasteboard. And we'll cut it the first time, see how it looks, and if we need to run it a second time, we can do that also. Now I know that my wasteboard is at least 1.5 millimeters low in that area that I had showed you earlier. So that's going to be the first surfacing, and there's no need to take an aggressive approach to this. Now I hit the simulate, and you can see that I had set up the rasper setting in the Pro Easel, and you can see exactly how it's going to cut the surface of the wasteboard. Let's go out to the machine and actually get this cut. I want to show you a close-up of the bit that I'm using. This is my 1 1/8 inch surfacing bit, or my 1.125 inch bit, and you can see I've used it quite a bit. The first step is to start the machine and home the machine, and that brings it right down to my XY0 home position. And this is the machine home position. From there, I'm going to actually probe the machine at this point, because I know this is the high point on the entire wasteboard. I think it's best to start from the high point. Now, if you knew on your wasteboard a high point was someplace else, I would move the machine over to that location, and I would do the Z-probe at that highest point. So now it's time to complete the checklist. I'll turn the machine on, and we'll get started surfacing this wasteboard. I always find it interesting to see the toolpath that is generated by the Inventables Easel software, because this first path going all the way across to the other side is really wasted motion, but it still gets the job done. And at this point, with the rasper set in the machine, it's going to continue all the way across just in this manner. Now at this point, you can see it surfacing really well, and it's getting cut down about that 1.5 millimeters as it should. Now it progresses across the entire surface, and you can see it getting over to that low area, how you have a little bit of a cut there, and as it moves across, it gets to the point where it's really not cutting at all. You can see a tiny little bit there, but as it gets to that low spot, there is no cutting whatsoever. So there's my 1.5 millimeter low point, because right now this router is not cutting any material at all. The lines that I had drawn on there are still there. I'm going to complete this operation so the areas that do need to get cut down will get cut down, that 0.06 or the 1.5 millimeters, and then we'll actually surface this board one more time. That's the only way that we're going to truly get it completely flat. As far as the feed rate, you can see here I'm running at 210 inches per minute, and that's doing an excellent job. The first pass is completed, and you can see that little bit of a groove there, and that's what you want. You want it to be able to cut just below the surface. And over here, it's a little bit same way, but as you look at the overall board, you can see where those low spots were and the areas that did not carve at all. So let's do this again. Now I'm going to use the probe on that area that we had just cut. Now that that's completed, I'll put the probe away, and I'm going to use the last XY0 position. There's no need to reset that. So then I'll just complete the checklist, and we'll hit the start button to carve it, and we'll go through this entire thing again. And I think you'll see that's going to be a big difference. As I hit carve, you realize I don't need to go back to that home position. It knows where to go, and that will start exactly where it needs to start. And it's going to cut down again that 1.5 millimeters or the 0.06 of an inch. And now you see that little ridge that's being generated all the way across. That's what you want. Now this, as a completed board, looks absolutely fantastic. It's perfectly smooth, and that is what you want to be able to have. That gives me a good foundation to be able to put the new wasteboard on. The other thing that it does, I've measured this, and it's exactly 28 inches by 28 inches. And you can see the ridge there being a little bit more than the ridge over there. That's okay. But now it's time to cut the new slats for the wasteboard. And I measured the 28 inches. I divided that by the 5 boards that I want. So basically about 5 3/8 of an inch is what I'm going to be using. As far as the length, I'm going to cut these just a little bit shorter than the 28 inches. I don't need it to be completely tight dropping into this little pocket, but I do want to be able to have it where the material will completely be encased in the pocket that I've cut out. After cutting all of these boards on the table saw, I like to do a test fit. Before I do all the rest of the milling operation, I want to make sure that these are going to fit into that pocket that I created. Now I'm putting the spacing just roughly 1/4 of an inch, and yeah, it fits in here just fine. There's a little bit of play on the y-axis, back and forth. Perfect, that's what I want. So with that done, now I can actually finish the milling operation on these boards. The first operation is to cut down a rabbet 3/8 of an inch deep, and I'm going to make it 3/4 inch long. And that way I can be able to secure the front and the back area of these boards. I can use the calipers to be able to set this, and all I need to do is just raise the bit right up to that point, and I have my 3/8 of an inch. I also want this rabbet about 3/4 of an inch deep. Now I can just move the fence over, and it doesn't have to be exact. On the CNC for Newbie New Carve, I think I set it at about 5/8 of an inch. I'm going to make this one 3/4 of an inch. Really doesn't matter. It just gives you a foundation to be able to secure the screws into the wasteboard. The bit that I'm using for this is a 3/4 inch straight bit. I'm also doing multiple passes. I don't need to try to get all of this material cut in one pass. So by taking 2 to 3 passes and to be able to get that to cut is a good, safe way to be able to do it. Of course, the last path is right against the fence, and that will give me the proper distance that I need to be able to complete this rabbet joint. Now this looks real good, so I'll do the same process now, front and back on all 5 of the boards. The other thing I need to consider, when I surface the board, I have that radius at all 4 corners of my wasteboard. Well, I have a choice. Either make the radius on these boards, which I'm choosing to do, or I could take a chisel and try to plane that down perfectly smooth. Well, you run the risk of having a little bit high, and I don't want to do that. The easiest way, take a socket the same size as my bit, which is 1 1/8 inch, and I mark it with a white pencil because that's the only way you can really see it on this melamine. And then after taking it to the sander, cutting this, let's do a test fit. And if you can see there, that looks real good. To me, this is a perfect option. I don't run the risk of having a high spot in the corners if I tried to chisel out this material. So this is perfect. I'll do this on all 4 of the corners. And now it's time to work on these T-slots. Because there's a little ridge that we have to deal with, I have to make this cut a little bit deeper. Best way to do that is to use the actual bolt itself and a pencil, and that actually sets the depth that I need. So at the router table, with that pencil line in place, I can move that right over there, raise the bit up, and I want to be able to remove the pencil line itself. That will give me just a little extra play to be able to have some maneuvering room when I slide that bolt into the T-slot. With all of those cut, it's time to test again. Yes, I do. I like to test. So now, look at that. It slides in perfectly. That's what I wanted to have happen. That way, that little ridge on the original wasteboard is not a factor at all. It's time to take these boards over to the drill press. I'm going to pre-drill all of the holes on the front and the back. You have to be able to pre-drill with this MDF. Otherwise, it's going to be a mess. So pre-drill the holes, front and back. I have my fence set up on the drill press, so there's no measuring necessary to get all of these drilled. To drill the holes in the center of these boards, I use the same measurement, but I use a 1/2 inch Forstner bit to drill down 3/8 of an inch. And again, I do this on all of the different boards, and I follow up with pre-drilling the rest of the way through with the same bit that I use on the ends. And again, pre-drill. This is a must. Please do not skip this step. It's time to actually mount these boards now, and I'm lining it to the edge where that ridge is, and I'm bringing it all the way to the front. The screws that I'm using is a wood screw. It's a 3/4 inch wood screw. And yeah, that's right. This is a little bit unusual from what you typically see, but I have found the wood screw does an extremely good job, and it does not cause any problems whatsoever. And it's a flat head, so it's below the surface, and you don't run the risk of the router bit hitting these screws at all. All of these boards now are in place, and we'll take the bolt and just test fit everything, and you can see how smooth this works. You don't need to buy the expensive T-tracks. It's not necessary. This will hold and work extremely well for many years to come. Now comes the fun part. We've got everything done now except for the grid work, and I do believe it's really important to be able to put the grid onto the Wasteboard. It's really useful. It helps you align the project, and with the grid that I'm using on 2-inch squares, it makes it where I can move the CNC machine very easily to any point that I want on the Wasteboard and know exactly where I am. Now I want to say this, as far as setting up the grid work in Easel, there's many different ways to be able to do it. The method that I'm choosing today is very similar to what I used in the XCarve Pro. I want to be able to see just how easy it is using similar methods and be able to make that comparison. This is the XY0 position for the machine itself, but this is going to be the work position. So all the projects will be able to go right to this point. And this is 1 inch over, 2 inches up. And that's going to be a very convenient starting point to be able to use as my reference point. Once the grid is on, then I'm going to show you how to make these little holes to use the dowel pins to be able to create your fence. Now when I set up the size of my project board, it's going to be a little bit different size. For the Wasteboard itself was 28 by 28. Now I'm going to use for this grid line from this start point of 0 over to this point is going to be 26 inches. Going on the y-axis from the front to the back is going to be 24 inches. I do not want that grid to go off of the board on the back side, and I want to keep it an even number so that my squares will work out 2 inches by 2 inches and I have a complete grid. Now that I've shown you the end result, let me show you how we got there. The project size is 26 by 24. The depth doesn't really matter. Over here on this grid, you can see right there, it's going to be 26 on the x-axis and 24 on the y-axis. The tool that we're going to use is this right here, the line tool. And we're going to start right down here at the bottom at the 0, 0 position. Do not really worry too much about being exact at this point. Just be able to put the points in place. The nodes are going to be close enough. You will notice the line turn red if it's parallel to the one that you just clicked off of. But that's not the important factor right now. Just get these lines in every 2 inches all the way across. I'm going to show you how to edit the nodes in just a moment so that it will be a perfect grid. Okay, this first section is completely done, and you can see all the different variations. It's not straight at all. And if we carved it this way, it would look horrible. Now this is one continuous line, so just click on one line, you'll get this drop-down menu. Now you can click on Edit Nodes, and you can click on one node, just like this, and it turns the dark color. And then you can put in the exact coordinates that you need to. In this case, it'd be 26 inches, and it's going to be 8 inches. And then you can move to the next node. Now this actually goes very quickly, so don't get upset with the fact that there's a lot of work here, because it really is not. Now as far as the bit that we're using, this is the 30-degree V bit, and we're going to be carving this grid down 0.03 of an inch. So this is my XY0 home position. So I moved it over 1 inch, I moved it up 2 inches, and that little dot is going to be my work position for my X and Y 0. The 0, 0 point for the grid is right there. That's where it'll start. Now I did my probe right there at that XY0 position. Now I do want to add one thing. Once you finish editing all the nodes on the x-axis, then you just need to turn and do one more full line on the y-axis just as you did, and repeat that same exact process. Edit those nodes, and then we start to carve. Let's turn the spindle on and see the end results. We'll hit carve, and let's take a look at it. Now this toolpath is actually very effective. It's going to start with that second line that we did on the y-axis. So this is where I began, right here at the top right-hand corner. So in essence, that was the first node, and it's going to come a straight line right down to this next node, and it's going to turn and go the 2 inches over and back up to the next one. it's going to follow each individual node at those points where it needs to turn. So this is a very effective tool path. It goes very quickly and it gives you a very precise grid. Now the other thing I want to point out, you notice it's not following a straight line all the way across. That's okay, because when this comes back and does the x-axis, it'll fill in those spaces. And it's going to be exactly on top of the lines that are there. You won't even know that it wasn't done to begin with. At this point, the y-axis is almost finished. It's finishing that last portion of this one continuous line. The router lifts up and it comes all the way back down to my XY0 position. This is where the x-axis begins. And you can see how that line is a straight line across, and it crosses over those other lines. And it makes for one continuous perfect line. Don't get upset the fact that there's a little bit of duplication and that it's going over an existing line, because this tool path is very effective, very efficient, and it's the quickest, easiest way to be able to do it. This is being carved at 140 inches per minute. The grid now is almost finishing. It's coming back to that final point, and that completes the grid, and it returns back to my home position. That grid looks absolutely beautiful. Now, the only thing I need to do is just wipe this off, and those lines look beautiful. Now, I don't want to take sandpaper, but I can take just a paper towel, and that will clean that up really well. And that makes those lines look really, really good. Let me get a vacuum. We'll vacuum that up. We'll show you the finished product. Now this grid was set at 0.03 of an inch. And you can see these lines look very, very good throughout the whole entire pattern. So that will tell you that this is very flat and it's level compared to the machine itself. So when you surface it, you get a good flat area underneath there. When you put this down, that too will give you a very flat surface to work on. Okay, the grid's done. Now we need to work on the fence, and I'm going to use the dowel rod system for that. And the first thing is, let's do a test. I'm going to drill one hole that is 0.522 inches in diameter and only a 1/4 inch deep. That's all we need. And I'm using a 1/4 inch upcut bit to be able to do this. A quick test with the dowel rod, make sure that it fits, and that fits absolutely fantastic. So that's going to work. Now the next thing that I want to do is put the holes right here to be able to establish a fence. I've used the dowel rods to drop in there, and that will establish the fence, and I can put these in and out depending on the type of project that I'm doing. So if I want to do a tiling project, I just pull these little dowel pins out and store them. And if I'm doing a regular project, I'll just drop them in. Now I'm going to put these along this axis as well as the y-axis, and I want them right on this outer edge. And again, this is going to be my XY0 work position for the 0, and yes, I can carve on the outside of that. Now this is the layout that I have. These holes are 0.522 of a diameter, and they're going to be cutting down 3/8 of an inch. Half of that is 0.261. So literally all of these are just set up on a coordinate system. So you can see I have this at a minus 0.261, and as far as the position, it's 18.375 off of this home position. And each one of these are set up exactly the same way, at 12.75, and again the minus 0.261. These are actually 5 5/8 of an inch. And the reason that I chose that measurement, because that's the same measurement down here that put these holes in the center of my boards. So since these were set up in that manner, I wanted to set this up in the same exact manner. I'm starting off with the 1.5 inches from my 0 position on both the X and the Y axis. So it's time to carve the holes. I'll go through the checklist. I turn on the router, and again, this is a 1/4 inch upcut bit that I'm using for this. And it's going to start at the very top on the y-axis and cut the first one and just move right down in a very orderly fashion. Again, this is a very effective toolpath that it's following. There are many different designs that you can use for a fence, but for me, I wanted to have something very simple and easy to be able to use and to be able to make taking it on and off very simple depending on the type of projects. And to me, this is the most simple way to be able to do it. It's just controlled by the dowel pin being able to be put it into the hole. And you can use as many dowel pins or as few, whatever is necessary. But this completes it. So now, turn off the router and let's just double check and make sure that these dowel pins are going to fit. Of course they are. Why? We already did the test. We know that they're going to fit. And using the coordinate system, as I showed you, to be able to get the exact placement of these holes, you can see the accuracy. It follows right to the edge of that line, and that's exactly what I wanted. That gives you a very accurate fence that's not going to have any reason to be out of square because, let's face it, the CNC machine actually did the cutting. So it's going to be 100% accurate following that exact line on both the x-axis and on the y-axis. And this gives you, to me, the best of both worlds. A very simple and accurate fence. Now don't forget, I'm going to provide the free files to you in the link in the description below so that you can create your very own wasteboard, save a ton of money, and have a very accurate, workable system that you can use in your shop on your machine. So if you like this video today, please, by all means, give me a thumbs up, and don't forget to subscribe to the channel. And I look forward to seeing each and every one of you in the next video that I do. And you can bet I'm going to be doing some work with the XCarve and with my other machine, the CNC for Newbie, New Carve. You're not going to want to miss out, so I look forward to seeing you in the next video. So for now, bye-bye. Can't wait to see you real soon.